Hi everyone, let's continue. Example 8. A printing company's book binding machine has a probability of 0.005 of producing a defective book. This machine is used to bind 3 books. Part A. Find the probability that none of the books is defective. Part B. Find the probability that all of the books are defective. Part C. Find the probability that at least one of the book is defective. Part D. Find the probability that at least one of the book is not defective. Okay, so here probability of defective is 0.005. Then the probability of not defective is 1 minus 0.05, which is 0.995. Then part A, find the probability that none of the books is defective. So we have 3 books, all of them are not defective. So that's why the probability is 0.995 to the cube. Okay, and what is this number? So let's calculate. Let me make this smaller. Okay, so 0.995 cube is 0.985. We round up, so 9851. Okay, 0.9851. And then part B, find the probability that all of the books are defective. So they're defective, so 0.005, and all of them are defective, so cube. So 0.005 cube. 1.25 times 10 to the minus 7. This is a very small probability. Part C, find the probability that at least one of the book is defective. Well, what does that mean? At least one of the book is defective, so at least 1 is greater or equal to 1. So greater or equal to 1 means it could be 1, it could be 2, it could be 3. A lot of cases. So it's better to consider its complement. The complement is 0 of the books is defective. Right? So that's why we can use 1 minus the complement. The complement is none of them is defective. And we already figured out this is part A. So 0.9851. And what do we get? So let's see. 1 minus point. Oops. Oh, I forgot to start a new line. 1 minus 0.9851. 0.0149. Okay. And then part D, find the probability that at least one of the book is not defective. Well, at least one of the book means it could be 1, it could be 2, it could be 3. So it's better to consider as complement. The complement is 0 is not defective. So none of them is defective. So all of them are defective, right? So this is 1 minus probability of none of them is not defective. So this is the same as all of them are defective. And that is part B, right? So 1 minus 1.25 times 10 to the negative 7. Well, because this is too small. So your answer is approximately equals 1. Okay. All right. Let's continue. Here we're gonna play some game. Okay. So let A be the events of people like football. It could be American football or European football. Doesn't matter. Okay. Part B. B is the events people like baseball. S is the sample space. So people in our class. Okay. And so we look at the Venn diagram. What is the region 1? So region 1, this is region 1. You can see region 1 is in A, but not in B. So we can write it down as it's in A and not in B, so it's in B complement. How about region 2? Region 2 is inside A and B, so A and B. Region 3 is in B but not in A, so that's why it's in A complement and B. Region 4. Region 4 is outside of A or B, right? So you can write it down as A union B, the complement, or you can use De Morgan's law. This guy equals A complements and B complements because region 4 is outside of A and outside of B. So that's why it's in the A complements and the B complements. Okay, and because I'm making this lecture video and so we don't know how many students in our class and how many of you like football or baseball. So let's just put some number down like to play with it. So let S be 26. Okay, let S be 26. Let's say number of people in region 1. So this means students like football but not baseball. Let's say the number is 11. And then region 2, students like football and baseball. Let's say it's 7. And then region 3, students like baseball but not football. So let's say it's 2. And region 4, the students like neither. So let's say this is 6. Actually, this data comes from my previous semester class. Okay. All right. So and check out when you add those all up, you get 26. And because all those 4 regions, there are disjoints, they don't have overlap, and then the entire region can be divided into those 4 subregions. Alright, so what is probability? Well, because outcomes are equally likely, and so that's why we can just use the number in that event over the total number. So here we have 11 over 26, 7 over 26, 2 over 26, which is 1 over 13, 6 over 26, which is 3 over 13. Okay, and then let's look at the following questions. What is the probability of a person like football or baseball? So like football or baseball, this is A or B, right? And then do you remember the general addition rule? That equals P of A plus P of B minus P of A and B. So P of A is what? What is that? P of A. Oh, by the way, because in our problem, we're not given P of A and P of B, we're actually given the subregions. So now we know A union B is like this penis shape, right? It's actually region 1, 2, and 3. So P of region 1, okay, and 2, and 3. So that's why we just add those regions together, mean the probability of those regions together. So 11 over 26 plus 7 over 26 plus 2 over 26. So that is 1820 over 26. And that is what? 10 over 13, right? Okay. So you, another student can solve this problem like this. Notice that the P of the union is we can compute its complement. So P of A union B is 1 minus the complement. But we already know the complement is region 4. So that's why we have 1 minus 3 over 13. We get 10 over 13. You see the answer are the same? So there are two ways to find the answer for part 1. Alright, part 2. What is the probability of a person does not like football and baseball? Okay. So here, let's see. Probability of a person does not like football and baseball. Okay. So actually this guy is the same as probability of A union B complement is exactly region 4. So that's why we get 3 over 13. So this is region 4. So far so good, everyone? Okay, let's continue. What is the probability of a person like football, given that he or she likes baseball? Okay, let's see. So probability of a person likes football, so that's A. Given that he or she likes baseball, baseball is B. Okay, this is a conditional probability. Whenever you see the word given, it means this is a conditional probability. So you have this vertical line right here. And what is the conditional probability of A given B? We have both events occur, given that B has already occurred. So we have P of B in the denominator. Alright, now let's see. P of A and B. P of A and B is region 2. And then P of B is region 2 and 3. So this is P of region 2. And then denominator, we have region 2 and 3. Okay, region 2, the probability is 7 over 26. Denominator, region 2 and 3, 7 over 26 plus 2 over 26. So that's why 7 over 26 over 9 over 26. 26 cancel. So we just get 7 over 9. Is that okay, everyone? Why 7 over 9? Because A over B over C over D is the same as A over B times D over C. So that's why you can think of this as 7 over 26 times the reciprocal, 26 over 9. So 26 cancels, so 7 over 9 right here. Okay. Next, what is the probability of a person like football, given that he or she does not like baseball? So, okay, so like football, given that he or she does not like baseball. So B complement. By the definition of conditional probability, this is the intersection over the P of B complement, right? And A and B complement, that is region 1, right? Region 1. And what is the B complement? B complement is outside of B, so region 1 and 4. So in the numerator, we have region 1. The denominator, we have region 1 and 4. So region 1, we have probability 11 over 26. Region 4 is 6 over 26. Okay. 11 over 26. 11 over 26 plus 6 over 26. So 11 over 26. And then we have 11 plus 6 is 17, right? 17 over 26. 26 cancel. We have 11 over 17. So far, so good, everyone. So don't forget, before you click start example, you can pause the video and try the example first, and then continue to play the video and check your answers. In this case, you can practice more. Okay, let's continue. What is the probability of a person like baseball given that he or she likes football? Right? So we have the intersection over P of A, because A has already occurred. So A and B, that is region 2, right? And then P of A is region 1 and 2. So P of region 2 over P of region 1 and 2. Region 2 is 7 over 26. Region 1 is 11 over 26. So 7 over 26, 7 over 26 plus 11 over 26. 7 over 26, this is 18 over 26. 26 cancel, 7 over 18. Alright. How about part 6? What is the probability of a person like football given that he or she does not like football? Okay. So like baseball, given that he or she does not like football. So A complement. Then we have the intersection, and then P of A complement. B and A complement is region 3. And then A complement is region 3 and 4. Okay, what is that? So let's see. Region 3, we have 1 over 13. Region 4, 3 over 13. Four over 13. So cancel. 1 over 4 is the answer. What is P of A and B? So P of A and B, this is region 2. So region 2 is, what is region 2? 7 over 26. And P of A right here. Region 1 and region 2, that's 18 over 26, which is 9 over 13. And then region P of B is right here. Region 2 and region 3, which is 9 over 26. Okay. Well, when we ask, are they independent? We're actually checking whether P of A and B equals P of A times P of B. So P of A and B is 7 over 26. Does that equal 9 over 13 times 9 over 26? Oh, the answer is no. Okay, because they're not equal, so we have A and B are not independent. So it means they are dependent. So far, so good, everyone. Okay, good. Let's continue. We call that the coin pick and flip example. So remember last video, we have the pick a coin and flip. And 90% coins are fair, 10% coins are biased, with probability of getting tail is 3/5. Pick a coin at random and flip. Find the probability of getting tail. So what we did is we let A be the event of getting a tail, B1 be the event of the coin is fair. B2 is the event that we picked up coin is biased. And B2 and B1, they are actually complements because you either pick the fair coins or the biased coins. Okay, so, and then P of A, so this is the picture. So this is the picture. B1 and B2, they are complements. And then what is A? So A is A and B1 plus A and B2, right? And then A and B1, we can use the multiplication rule, also called the breakfast rule. Remember, you want to eat apple and banana, which one you eat? You can choose to eat apple first and then eat banana, or you can choose to eat banana first, then apple. But here, what information we have? Well, we must pick the coin first. After we pick the coin, then we know what's the probability of getting tail. Okay, for that coin. So that's why we have P of B1 times P of A given B1. And similarly, this guy, we have P of B2 times P of A given B2. P of B1 are the fair coins. We have 90%. So we have 9 over 10. And if we pick a fair coin, the probability of getting tail is 1/2. Alright? And then P of B2, 10%, so 1 over 10. P of A given B2, so if we pick the bias coin, the probability of getting tail is 3/5. So that's why we get 51 over 100. Okay, so this is what we did before. Okay, so today, let's ask these questions. Given that the result is tail, what is the probability that the coin is fair? Okay, so given the result is tail, so this is a conditional probability. So we have P given A, okay, given the result is tail, what is the probability of the coin is fair? So that's B1. So that's why this is a conditional probability P of B1 given A. And how do you do this? Well, you can use the definition of conditional probability. That is P of the intersection over what is given. So P of A. Okay, B1 and A. Multiplication rule. Which one happened first? We must pick the coin first, and then after we have the coin, we can get we can ask what's the probability of getting tail, right? And the denominator, we already calculated. The denominator is 51 over 100. And then the numerator, P of B1, actually is this part. Can you see? This is 9 over 10 times 1/2 over 51 over 100. Okay, you can, because of A over B over C over D is A over B times the reciprocal. So this is like 9 over 20 times 100 over 51. This cancel, we get 5. 4 times 5 is 45. So the answer is 45 over 51. Okay, everyone? Alright, so how about if I ask you what is P of B2 given A? Well, you can, so everybody please try this. Pause the video here and try this. Okay, have you done? Okay, so similarly, we can do B2 and A over P of A. And then this is P of B2, P of A given B2, P of A. And then we have 1 over 10, 3 over 5, 51 over 100. So that's 3 over 50 times 100 over 51. So they cancel, we get 2. 2 times 3, 6. And notice that this guy also equals 1 minus 45 over 51 because they're complement of each other. Alright? Okay, so that is session 3.6. So if you have any questions, feel free to ask me. Bye!